Hello everyone, this is DEEPAK Joshi, and today we are going to solve another Geeks for Geeks problem, that is left view of binary tree. It's a very standard problem. Like what we need to do in this particular problem is we have to find out the left view of a binary tree. That means, let's say here we have given an example that is 1, 2, 3, 4, 5. So we have to find out कि अगर मैं इसके left में होता तो how this tree will look like. So if I'll be at the left side of this particular tree, then I'll be able to see only 1, 2, and 4. This is what we need to return. I guess so. Yeah, definitely. This is what we need to return. 1 to 4 is the left view of this particular binary tree. And for this particular binary tree, what will be the left view? Okay, let's imagine that I am on the left side of this particular binary tree. Then I'll be able to see 1, 2, 4, and 5. Yeah, that is what it says as well. Okay, so right now I'll be going with the basic approach that comes to my mind, that is recursion. Okay, I will follow this particular approach in this particular video. So what we will do is we will first have a vector that will store the final answer or the left view. Okay, yeah, and we'll have a private function that we can call helper function. Okay, what it will do is it will have the node root and the level at which level we are. I'll tell you why we are having this, and it will also have call left view. Okay, that is our final answer. Yeah, so what I'm planning to do here is I'll pass my route to this particular helper function and make left calls, and I'll check I'm on the left, and if the particular level and the left view dot size matches, that means that is my first level. Okay, or the second or third, depending on the level I am on. Let's say I am on this particular one. Okay, this particular one. In this case, what I'll do is I'll call my helper function with root level will be 0 and my left view. Okay, and I'll return my left view because I have passed it with call by reference. Now, what I'm able to see here is that I'll be calling one. Okay, and my current level is 0. That means, and my size of left view is as well 0. That means I am on the left extreme. Okay, so it will like put 1 into my left view. Now my size of the left view is 1. Oh, that is great. Now I'll call recursion or the helper node with 2. Then in that case it will check, okay, the level is 2 and the size level is 1. Okay, and the size is 1 as well. That means I am on the left side. It will then make a call to left. Okay, it seems pretty straightforward for a binary tree like this, but what if the binary tree looks like this? That means I'll be able to cater 1 and 2, but how I'll be able to cater 3, 4, and 5? That will be taken care. That means we have to make right call as well from the node. That means initially 0 will be passed in as the left as the level, and the left view will be empty. It will check, okay, that 0 is equals to 0. That means I have to put 1, okay, into my left view. Now the size of my left view is 1, and I'll be moving to another, like I'll be calling nodes left. That means I'll be on 2, and then I'll check, okay, I'm on level 1 and the size of level view left view is 1 as well. That means put 2. Now what? I have nothing to go from 2. That means I have to revert back, okay, or revert back and then make a call to right of 1. That means I'll be making the right calls as well. No, only left calls. I'll be making a right call from 1 to 3, but I'll check, okay, what is the size of my left view? I've put 1 and 2, that means 2, but I'm still on level 1. That means that no pushing to the vector will happen. Then the left call will happen from 3 to 4. Okay, and it will check I'm on level 2 and the size of the left view is also 2. That means this is equal, put 4 into the left view, and then it will check no left exists for 4. It will make a right call for 4, and then eventually the recursion will happen and it will put 5 as well in the left view. Okay, so what will be the, so here what I'm doing is, if root is equals to null, just in each case simply return left view. Okay, or no need to return, simply return because it's void. Oh, I'm not writing Python, okay. So I have to specify the return type as well. Okay. Now, what was our condition? If the level is equals to left view dot size, that means we have to do something. And what is that something? That something is put uh, something into left view, and that something is roots data. Easy peasy. And then make a call to roots left and increase the level by 1 and pass the left view as it is. And we have to make a right call as well. That means make a right call and increase the level by 1, and this will be right view. Simple as that. I guess this is what we need to do. Let's compile and run and check whether we have any syntax errors. I guess we don't have, but let's see. Because I always doubt the code which is written by me. Helper node root. Okay. Seems to be pretty slow. Okay, please work. Mhm. Seems like it is not working. Is that an issue from my internet? I guess so. Yeah. Ready for evaluation? Yeah, it is an issue from my internet only. Okay. I guess it failed. Then it restarted again. Retry mechanism is working. Okay. Let's wait for the retry mechanism to run again. It says there is nothing called right view was not declared. Okay. 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 There is nothing called right view. Yeah, it is right because there's only left view. It retried and then it failed. Syntax error written by me. I know. Okay. Please don't fail this time. Oh, my GitHub failed. Internet issues, man. Only two signs of Wi-Fi exist. Oh, by the way, I have shifted to cursor. Yeah, cursor is not there. Yeah, I've shifted to cursor. You can give it a try. It's a nice text editor. Okay, it passed. Let us submit. And please don't mind my internet connection. It is still failing, but yeah, somehow GFG is capable of running all my test cases on their EC2 instance or something else. But yeah, maybe it is a EC2 instance, or yeah, maybe, or maybe something else. I don't know. But what I know is they use Spring Boot Java. Probably I may be completely wrong. Yeah. Ready for evaluation. Just wait. अगर ये live होता तो I should have asked you some question, or you should have asked me some questions, or maybe we can go through the code line by line. So what it does, we have created a vector. Okay, do you know the difference between vector and array? Vector is dynamic. That means it can dynamically increase or the size. Okay, the algorithm of vector is written in such a way that it starts with 2, 4, 8, and then it doubles. Oh, I saw a pop up here. I don't know. Yeah, I'm sure that it will work and run and it will get submitted. But yeah, okay. So vectors work in a way that it doubles its size whenever the last to last element gets filled. Okay. Then we have this recursive function that is called helper. In helper, we are passing root, the level, and the left view. Here we have an edge case if root, because I am doing this root ka data. What if root is null? So we have to take care of those things, and Yeah, it sort of acts as a base case as well, but it's more of a edge case, not of a base case. Because yeah, because like let's say, could you please, yeah, let's say I'm on 4, so I'll be doing root left. That means I'll be passing a null here. So it's just an edge case because I'm doing root ka data here on line number 35 to be more cautious of not doing a pointer operation on a null. That's why I'm doing this. And then I'm comparing the level with the left view, not size. If the size and the level matches, put that data into my left view. Okay, and yeah, then I'm making a left call and then a right call. And in both the cases, I'm increasing the level. Okay, I guess so. It is not going to run as my internet connection is pretty slow, but yeah, it will work. It will work. So we can probably end the video here. And if it doesn't work, please do let me know in comments and we'll fix this. I'll give you a updated version of the code if it doesn't works, but I'm sure that it is going to work. Yeah, see you man. See you in some other video. Bye bye. Take care.